Okay, sample of a gas occupies volume 1.820 liters at STP. What pressure in atmospheres would it exert if transferred to a 1.425 liter vessel in which the temperature is raised to 25.2 degrees Celsius? This is another combined gas law problem. The only difference here in this problem, we're asking to solve for pressure. So pressure is what we are going to be looking for, specifically P2, because our first sentence again gives us our initial conditions for this gas. We're told that the gas presently occupies a certain volume, 1.820 liters, at standard temperature and pressure, so we know those values. We're given the final volume, V2, and we're given the final temperature, T2. We need to convert that to Kelvin, so we're going to add 273.15 to that given number, and our temperature is going to be 298.4 kelvins. Notice we only have one decimal place there, so we can only have one decimal place in our answer. So again, our combined gas law equation given at P1 V1 over T1 is equal to P2 V2 over T2. In this problem, we're asked to solve for the final pressure, P sub 2. So let's do our algebra and then substitute the values in. We're already assigned the values to everything. So let's do the algebra. P2 then is going to be equal to P1 V1 T2 over T1 V2. Okay, now let's substitute in. Initial conditions were STP, and they want the pressure in atmospheres. So let's put in 1 atmosphere pressure, initial. Our initial volume, let's scroll back and get that number, 1.820 liters. 1.820 liters. T2, our final temperature, 298.4 kelvins. So we have 298.4 kelvins. And then downstairs, T1, initial temperature was standard temperature, which of course is 273.15 kelvins. And then our V2 was 1.425 liters. 1.425 liters. Kelvins cancel, liters cancel. We're left with our unit of atmospheres, pressure, which is what we're looking for. And now we do the math, and our value for P2 is going to come out to be 1.395 atmospheres. We do have 4 significant figures on this answer. We have our 4 significant figures in 3 of these variables. Our 1 atmosphere pressure, of course, is an exact number.